Hello again. This is your life science tutor, Mr. Mhlongo from Limitless Academy, an NPO in Guatabega. We help with tutoring learners. Today, we are going to be talking about a process called paternity testing using blood groups. How do we test for the paternity of a child using blood groups? But to just have a little history about blood groups. Okay, when it comes to blood groups, there is the 1, 2, 3, 4 rule. So the 1, 2, 3, 4 rule, what does it say? It says that there is one gene for blood types, and then 2 alleles. A person can only have 2 alleles. That is, a person can only have 2 alleles. But since blood groupings fall under the category of multiple alleles, that means characteristics controlled by more than one allele, by more than 2 alleles. Okay, so we then have 2 alleles. A person can only have 2 alleles, but there are 3 alleles in all for blood groups, and then we have 4 blood types. Okay, so when it comes to 3 alleles, that means we have A, B, and O. So these 2, since they are capital letters, we know capital letters mean what? They mean dominant. And then we have I, which is recessive. That means A and B are both dominant, and then I is recessive. And then for blood types, we have blood type A, blood type B, blood type AB, and then blood type O. So there is 4 of them. Okay. So it's one gene. A person can only have 2 alleles. That means a person can have either A homozygous or B homozygous, A heterozygous or B heterozygous, or O or AB. Those are your alleles. And then the blood type groups, these are the types A, B, AB, and O. Okay. When we are testing for paternity, that means we are looking for the father. Here. So we are looking for the father using what? Blood groups. We are not using a DNA profile. We are using blood groups. Okay. This is how you write or describe paternity testing for using blood groups. This is how you write it. Remember, in life sciences, it is better when you are given a question that requires you to write a lengthy answer or a process. It's better if you write it in point forms rather than a full-on paragraph. It's better if you write it in point forms. And we are not looking for one-word answers. Whenever you're explaining something, when it comes to life sciences, whenever you're describing something, when it comes to life sciences, you always have to know the cause and the effect. Always state the cause and then state the effect of that thing. Okay, in this definition, we're gonna have the cause and we're gonna have the effect of it. Okay, so the first thing you need to write that must always be in your head when you are talking about things that can be inherited. It's better and safer to always start with this point. A child inherits one allele or whatever characteristic that is being talked about. Okay, but in this case, because we're doing paternity testing, we are going to deal with alleles. A child inherits one allele from both parents. What does this mean? It means during meiosis, you have what? You have the process whereby there is a segregation separation of chromosomes and chromatids and all those separations. What do these separations lead to? They lead to you having only one allele from each gamete. The gametes from the father have their own alleles, and the gamete from your mother has its own alleles. So when these 2 come together, it's one allele from your mother, one allele from your father. Okay, so that's why we say a child will inherit one allele from both parents. So ingane isitholile allele yodwa, this one allele from umzali. What then happens? Remember, we are testing for the father, we are looking for the father using blood groups. So after that, if we already know this, then we need to be able to determine the blood groups. So what do we write? Blood group of a child, a mother, and a possible father is determined. Okay, so the blood group of a child, a mother, and a possible father is determined. Or we could say are determined. Yeah, are determined. Okay, so we need to be sure, we need to know each blood group of the person, the mother, the father, and the possible father, and the child themselves. So we know what we're comparing it to. Okay, so what happens after that, if the blood group of a child does not match with the parents, with the blood group of the parents, obviously, when you're saying parents, if it doesn't match with both the mother and the possible father, what does that mean? The conclusion is he is not the father because the blood groups do not match. Okay, what then happens if the blood group of a child matches with that of the possible father? Now, their blood are matching. They are both A, or they are both AB, or they are both O. So there is a match there. What does this tell you? As much as they can match, it doesn't necessarily mean that he is the father. Okay? So those results, we cannot say without a shadow of a doubt that no, he is the father. No, we cannot say. Because, okay, if the blood groups of a child matches with that of a father, it is not conclusive that he is the father. We cannot say that it is without a shadow of a doubt that he is the actual father. So if we cannot say that he's the actual father, what is the reason for that? It's because there are many men who have the same blood group. So that is how we test for paternity using blood groupings. Thank you. See you next time.